Hello, everyone. I am Eldad. Thank you, Chris, uh, for the introduction. So my topic today is low test smells. Kind of a weird topic, and it gets some attention, but let's dive into it. Uh, Before then, about myself. So this is my family, my wife, my child, my dog, and there's a new member to the family. It's a guinea and pig, very cute, tiny rodent. And when my son took a look at her, he looked at her colors and her shape. He immediately named her Checkmate. That was her name. So both because of her colors, the shape, it's like the squares on a chessboard. And if she stands erected, she kind of looks like a bishop. So I think that's what pops it into his mind. You can check me out on LinkedIn and on Medium. I post articles on various topics related to automation, quality assurance, robotic process automation, and of course, performance engineering on my LinkedIn and on my Medium. I hold a bachelor degree in software engineering. I've been an automation engineer for 12 years, and performance engineering, in its more common sense, I've been practicing that for over 5 years. I've been dealing with performance engineering at lower level, for example, networking stuff, but in the more common sense or more the popular or casual term of performance engineering, that was more of the case in the last 5 years. And I was here. I was already here in the previous conference in October, and it was great. It was very ingratiating, and it was a wonderful experience. So when Chris offered me to come back for another session, I said, of course, it's my pleasure. The last time I was here, I talked about collaborative efforts in load testing or performance testing. So today, I'm going to do the exact opposite. Because last time I taught you all how to cooperate, this time around I'm going to teach you how to compete. Because I truly believe, and not only a belief, I think it's well substantiated by evidence, that in order to be successful at any endeavor, you would have to be able to do both. Okay, so here's a dream coming true for me. I'm using Dragon Ball on my presentation. So fusion, we have competition and cooperation fused together into this monster known as coopetition. So you have to be able to do both. Okay, if you're overly cooperative, you're a pushover, you're easily manipulated, you give too much trust in people, and you become very ineffective at imposing barriers, imposing regulations. If we connect that with the previous talk we heard from Naveen Kumar, imagine that you need to impose a barrier. Hey, everyone who uses Log4j, you have to use the latest version. You have to do this and that in order to avoid the vulnerability. And imagine that you're overly cooperative, okay, or the psychological term is overly agreeable, and you avoid the confrontation and you don't want to do that. It's terrible not only for you, it's terrible for the organization. Now, if you go to the other extreme, if you are too competitive or too antagonistic, first of all, you're losing a lot of opportunities. You're burning a lot of bridges. You will be perceived by your peers as being arrogant, selfish, maybe manipulative in some sense. So you don't want to be at these extremes. You want to be able to mingle. You want to be able to do both. And how do you do that? Well, let me just drink a short cup of coffee. I think that a really good guideline, if you want to be balanced out in this area of competition, cooperation, cooperate with people, compete with ideas. Okay, so when you cooperate, you commit to the people that you talk to. And when you compete with their ideas. You're not challenging the person, you're challenging the idea. I think it's very important, very useful to be able to do both things, especially in the tech industry. Because believe it or not, the tech industry is a battle of ideas. Every day when you go to work, well, or you work from home now with COVID around, but every day when you go to work, you're making a claim. That's a typical thing that you do. Even if you don't notice that, you're making a lot of claims. You're making a claim that some idea is a good idea and it should proliferate. We should do more of that thing because it's good. And other ideas are bad ideas. and they should diminish. We should not use them too often. Now, in the tech industry, we might have different terminology. We might say good practice and a bad practice, or an anti-pattern. We have a lot of terminology around this, but at the essence, at the core essence, there is a deep philosophical meaning of good ideas and bad ideas. Good ideas proliferate, bad ideas diminish. But this is, of course, the black or white extremes. There are some shades of gray. So the shades of gray in this respect would be things that are not necessarily bad, but they deserve attention, right? We should look at them. We should spend some time understanding why did they occur or why did it happen. And they could imply other things. So in coding, in the software field, one way to express this thing is the idea of code smells. So code smells is a very popular notion. So because it's a popular notion, we're going to stand on the shoulders of giants. Here's one giant for us. This is Mr. Martin Fowler, a very renowned object-oriented programming guru, and programming in general, a very reputable source for programming. And in his book, 2009, Refactoring, Improving the Design of Existing Code, he argues that a code smell is a surface indication that usually corresponds to a deeper problem in the system. Poof, big stuff. But if you look at this, it's very similar to what a doctor do, right? So when you go to your physician, you're typically going to tell them, I have a headache. I'm having trouble to get some sleep. I lost my appetite. Stuff like that. You tell them about your symptoms, and the physician would take a look at the totality of those symptoms and try to understand what's the problem is. Yes, he's going to confirm that with imaging or other tests, but in general, he's going to look at your symptoms first, right? So a code smell is an example of a could be bad practice that deserves some attention. Let's take a look at a couple of examples. Very straightforward, very common example is duplicated code. So you read the code base and deja vu. You see the same thing over and over again, right? You see the same loop. You even see the same variable names. So a quick refactor for this would be, of course, to make a function out of it, or an object, depending on your realm of programming. But then again, you need to ask, why did it happen? How did we end up in this situation? So right from the get-go, we kind of get a feel of what is the benefits of having smells, of the code smells paradigm, because now this thing has a name. It becomes a thing. It becomes alive. It becomes something that we can address and talk about. You could also Google search certain stuff, and you can go to your colleague and say, hey, so-and-so, reputable source, they argue that this is a code smell, and here's the name for this. Right? So because it has a name, it can be addressed, it can be discussed, it can be shared as an idea. Okay, remember, this is the battle of ideas. Another example is a dead code. Okay, so dead code is a piece of code that runs. Okay, it executes at runtime, but it has no effect on the actual outcome. And again, of course, you can mark that down off as a comment. You could do stuff about this, but you also have to ask yourself, how did it happen? Why did it happen? What was the communication problem that led us to this place? Data clamps. Okay, so you have lots of functions in your code base, and they all seem to get exactly the same parameters over and over again. There are some slight differences, but they repeat themselves all the time. And of course, there are some refactoring that can be done around this. But again, not only the refactoring, the short-term solution is also to understand how did we end up in the situation in the first place. So we stand up on shoulders of giants. Let's stand up on the shoulder of another giant. This is Professor Arje van Derzen, a professor at Delft University of Technology from the Netherlands. And he came up with a very interesting idea in 2001. So this is only 2 years after Martin Fowler's book. He argued, in his experience, that tests, or unit tests in his case, deserve a different set of smells. Okay, so there are different considerations to take into account. And that was in 2001. That was his first publication. In the 20 years since, and yes, 2001, that was 20 years ago. A lot of millennials out here don't really they didn't really have the chance to swallow that frog to understand that 20 years ago is not the 80s. Okay, so millennials, the 80s, that was 40 years ago. 2001, that's 20 years ago. So in these 20 years, Van der Zen put up a tremendous amount of work demonstrating empirically, not just theoretically, but empirically, the benefits of test smells. And let's take a look at them. Now, in his work, he generally regarded unit tests as as the example, but you could immediately see that becoming relevant to other fields of testing or automation. Let's take a look at this. Resource optimism. So you write your test suites and you rely on some external resource like a server or a socket or a web socket or a file, could be, and you're optimistic that this resource would be available to you at any execution or available to you to the same extent. Okay, so imagine that you have some flaky kind of resource and it could lead you to trouble, right? You start executing these tests over and over again and they start to fail and pass correspondingly. So this is a flakiness inducing smell. There are some work that are conducted in this fashion. So the immediate refactor for this, of course, to be using mocks. But again, beyond the refactoring, you should ask yourself, why did it happen? Conditional test logic, another test smell. Okay, so it is usually a good advice to avoid conditional statements in the test code, like if statements or exceptions. It's generally a good idea. Maybe in the internal infrastructure stuff, you might be able to get away with some conditional logic statements or flow controls. But in the test code itself, you better not do it for two reasons. First of all, it becomes unclear what the test does. And moreover, it can also induce flakiness to some extent. Assertion relate. So you asserted that 1 equals 2, but there is no actual context to it, and there is no message. Okay, in most frameworks, you could assert and then declare a message. Okay, if it fails, here's what I want you to print out. But if you don't do that, then your test fails and nobody knows why, and people really have to dig into this, into the code base or something else to understand what happens. So assertion relate is another test smell, and of course this would apply to many realms of testing, not only unit testing. So the argument, my thesis here in this talk is, I think we could come up with a set of smells that are more specific to performance testing and load testing. And lo and behold, I wrote such article a day before the previous conference, on the 5th of October, excuse me. So I came up with 6 smells that could ruin the performance testing validity. So right from the get-go, it means that these smells deal with the execution or planning of the test. And let's take a look at them. So Utopian data storage. Utopian data storage refers to a data storage that is overly organized or even empty. So it's too easy, but it's overly organized for your load tests. You see here, everything is neatly organized, and this is not the real world. The real world is that your database or your storage, your data lake, to be more precise, goes through migrations. Some users abuse the system in some other ways, and there are things that you cannot predict. So if your data storages are utopian, this is very similar to Aikido practice. Let's take a look at this. So yeah, if your opponent just waiting for you to flip him over, it's going to work. But in the real life, when you have a resistant opponent, it's not going to work very well. So if your data storage is overly organized, then your load test is not very realistic, or a performance test is not very realistic, and you should try to predict what's going to be the state of your database in future. An idea could be to consult with your DBA and understand further what could be a future result of your data storage. So the loopback flag, I love this. This is It's more relevant for microservices architecture. So you have a user. The user send some esoteric request to the gateway. The gateway propagates to the authentication server. So it authenticates the identity of that user. If it's authenticated, if it's successfully authenticated, then it propagates later to the items or whatever business logics that you have in your architecture. But here's the problem. In the load testing sphere, we don't want to authenticate, right? Because imagine that the authentication is some third party, okay? Because usually we use third parties to authenticate. We don't authenticate ourselves because there is an entire art to how you authenticate. So what do you want to do? You want to remove this part. You want this to be bypassed. And the very naive solution is to implement some code in the gateway that says, okay, if you send me some metadata that indicates that this is a test request, like some header or proprietary property, like a query string property, then I will not authenticate and I will go straight to the items or the business logic itself. And this is wrong, not because of the security issues that it could, because the security issue is not the deal here. The deal here is that it's not a realistic scenario. Now you shred off this entire uh, uh, request or flow of requests that could come from this gateway to the authentication, and it could lead to some performance issues. Okay, so anything could happen in this intercommunication, and it could be unpredicted. And if you remove that altogether and you just use some internal logic to bypass it, then now your testing is less realistic than it could be. So there is a better alternative, and that's using mock. Okay, so create some mock authentication server, and now this gateway is completely agnostic of its purpose. It doesn't know that this mock authentication is a mock authentication. For all for all intents and purposes, this is an authentication server. So there are plenty of tools out there that can help you creating better mock servers, especially in the RESTful and HTTP realm. In the IoT realm, you might need to work a little bit harder, but it is possible. So use mocks. The same way that we saw with resource optimism. If you have a resource that you don't know how it's going to interact in the test, mock it. So same way here, just the mocking is external. Some would call it stubs and other would call it mocks. I don't always understand which is which, but whatever it is, use it. It could really help you. Auto scaling. So Rich talked about this in his presentation. Wonderful presentation by Rich about how scaling could really set things off in the load test. So if for whatever reason you set up, let's say, some magic number like 8 pods for this microservice and 6 pods for this one, and other kind of arbitrary numbers, then you're not really testing what's going to happen when a scale event occurs. Okay, so scaling up, if you add another pod, okay, and it has a warm-up time, for example, and it starts taking off from the load before it's ready, this is a problem. Okay, it could lead to unintended consequences. The opposite is also true. If you scale down, you shut one pod down because you don't need it anymore, but it still processes some requests. Okay, so it needs a cooldown time. If it's not taken care of, then you can really harm the user experience, right? Because you cancel out requests that could be important. So it should be part of your testing flows. If you see these magic numbers, we have 8 pods and 6 pods of that, and when you see these kind of arbitrary numbers, this should give you a warning. Hey, what about scaling? How is that being accounted for? So bogus workloads. I love Mr. Bogus, another childhood hero of mine. Mr. Bogus is awesome. But workload models are a huge topic, and it really is an entire workshop. I think it's a wonderful topic to talk about. But the idea behind bogus workloads is that workloads are constantly being reviewed and revised. You don't come up with numbers right from the get-go, hey, I expect 40 requests per minute or something like that. You constantly look at the production environment to see, to forecast. You try to forecast the future and see what a future load could be, right? And of course, you can consult with marketing, but marketing only know about the user base, and it is important. It is important to know what your user base might be in the future, but it is more important to know what kind of loads your environment would have to deal with. So another consideration in workloads, for example, would be humans versus things. So things, okay, so sensors or mobile devices are predictable, right? Because they always do the same thing, and they don't get sick, they don't get married, they don't have children, they don't have this kind of life stuff that could set them off. Humans are less predictable. So if you work from 9 to 5 and everybody comes back home at 5 and tap into your application, then it's very different. It's very different. And people usually have think time. Okay, so they think while the application comes up, or something distracts them for a moment. So your workload really has to be reviewed all the time. You have to really carve the load testing efforts in concordance with what's happening in the production environment. Perfect timing. Okay, so if you go to work at 9 a.m., for example, and you run your load test for 1 or 2 hours, and then you spend the rest of the day analyzing what happened in that load test, the consequence of that is that you are only running your load test at very given time frame. And what happens, for example, if you have some scheduled task in your server under test that pops out every, I don't know, like 12 a.m., excuse me, and it could affect performance, right? Because it competes for resources or for whatever reason. So if you're not testing different periods during the day, you're more likely to miss some effects of time. So the solution for that is to conduct longitudinal soak testing. Okay, so yes, do your 8, 12, 20 hours of load tests, even if not in full capacity, but you better have a good feeling of what happens over the day to your performance testing all over the world. Okay, so this would be the last smell that I'm going to talk about. This refers to the situation where you only run your load from a single from a single region. Okay, so let's say all of it happens in London or whatever region that you happens to have, but your real application actually takes loads from multiple regions. So what happens if you use some solutions like AWS's global accelerator? Okay, so and how does it affect your caching? Okay, maybe your caching is also region-based or region-aware. And there is a article that I contributed to Redline 13's blog about this very topic of how you make your load test more realistic in respect to caching and in respect to regional caching. Okay, so if you have any kind of regional caching solution and global accelerators, AWS global accelerators, so better check that out and pay attention to how your system under test behaves when different regions are taken into account. So I'm going to wrap it up. I want you to come up with your own smells. Think about problems that could occur. Think about symptoms that poor testing design could lead to, and give them a name. Let them become a thing. Let them become alive. Of course, the only thing I looked at here are smells that are related to execution or planning. But similarly, you could find a lot of smells that are related to the analysis. And for that, when credit is due, credit is given. My co-speaker, Naveen Kumar, has a wonderful series, Statistics for Performance Engineers. So he goes into the details of statistics. So improve your knowledge of statistics, of how to analyze your load test results better. And again, you could come up with smells that are related to these types of topics. But come up with these smells, because it can really help you create a language that is easier to understand. So that would be all, and thank you for listening, and I'm really looking forward to hear your questions.
All right, very good. Thanks, Eldad. We do have some questions, but we can definitely take some more. I'm going to post a couple questions on the screen so you can, and everyone can see them here. There's a couple from Nabeen that he asked while you were speaking there.
I'm not really understand the context of the question. Will it not create load on the gateway? Uh, what does it mean? The gateway is, in my example, the gateway is the loaded application that I want to test. So I need some more context for this question.
Okay, so Nabeen, please, he actually has another one here. Let's see if this one. Um,
Okay, so one tool that I really enjoyed using is Hoverfly. Hoverfly is a Golang-based mock tool. It acts as a proxy, so it means that if you take the gateway and you connected that to a proxy, and the proxy is this Hoverfly server, so you don't need to change anything in the code base. First and foremost, you only change a URL or something like that, and it can act both as a recorder and a simulator. So you first record the traffic, and then you switch it around to make it a simulator based on that recorded or pre-recorded traffic. So Hoverfly is an awesome tool for that, but of course you can experiment with many other tools. There are plenty of them.
well, it looks like Nabeen came back with hopefully some more information. This was with regards to the question that he asked that you weren't sure about when he asked about.
When you separate authentication, I mean during well, if I think I need to clarify this question. I want to separate the authentication because, for example, let's say that it's a third party that you pay for, and you are limited with the amount of authentication, for example. So you don't want to test the authentication server, and of course, you also assume if you paid for the server, you assume that they have already tested that for you. So it kind of makes no sense to pay for something and test it at the same time. So that's the premise here. But anyway, there are plenty of situations where you don't want to test all of the components of your system. You want to remove some of them out for maybe for root cause analysis or for some other purposes. But it could definitely happen. So when it happens, use a mock and don't do a bypass or code-based bypasses to achieve that. That's the point.
Okay. We still have time for another question here. While we're doing that, I will tell you that you've gotten some nice, not a question, but just some nice things that people had to say here.
Yes, thank you.
Oh,
I appreciate that.
here's a question for you. Oops, no, that's not the. That was not the question. Hold on, they're coming in fast now.
Yeah.
Here's the question.
I've heard a lot of good things about Wiremark. I have not experienced that myself. I've heard a lot of good things about them, but I cannot recommend because it's not something I've personally experienced. If you experienced that, if you had any experience with if you experimented with Wiremark, please share. I'm more than interested to hear. I've never experimented myself.
Okay, great. And just so you know, Nabeen did respond, and so I guess you did answer his question there. So,
Oh,
uh,
okay. I'm happy to hear that.
so very good. All right. Well, listen, I'm glad that you were able to take some questions there. And once again, Eldad, thank you very much for being part of LoadTestWorld.
Of course, my pleasure. Thank you. Thank you for the welcoming. And I'll be here later in the panel.
Oh, yes, yes. Thank you for pointing that out. Yes, I forgot to mention that. Yes, so that'll be in 2 hours. Eldad
Yep.
will be part of the panel, as well as Rich, who spoke at the beginning, and Dave Millett. who will also be joining the panel. So that'll be in 2 hours from now.
Awesome.
Let's see. Oh, wait. You know what? We did get one question here. Let me just see real quick here. Okay. You know what? I'm going to put Eldad one more question up here, and let's just see if you can answer this quickly.
Okay, when third-party gateways are involved, and in the event of our API can be called and tested separately, is it really needed to mock third-party gateways? I could well believe that there are some cases where you don't want to mock the third-party gateways or third parties in general. There could be some situation. The point of that is in these situations where you do want to mock third parties, or not even third parties. They don't have to be third parties. In these situations where you do want to bypass those components, don't use a code-based loop flag or something like that, but use a mock. That was the point. But of course, it's not an immediate conclusion that every third party should be mocked. Of course.
All right, great. All right, thanks, Eldad. We'll talk with you again in a couple hours.
Sure.